Good day, everyone. In this presentation, we'll be discussing about ANCOVA, which is analysis of covariance. So, what is ANCOVA? Prior to this, we need to know what is variance first. Variance is a measure of how much the values of a dataset vary or spread out from the mean average, which is taken from a sample or population. In simple terms, to tell you, it tells us how much individual data points in a dataset differ from the average of a dataset. A high variance indicates that the data points are spread out over a wide range of values, while a low variance indicates that the data points are clustered, which means closer to the mean. So, what is covariance? Covariance is measured of how much two variables change together. So, if we take any data set, there are variables which are independent and dependent, which changes according to time or which changes accordingly. So, covariance is measure of how much these two variables change together. It also tells you whether one variable tends to increase as the other increases, which we call as positive covariance. Also, which if one variable decrease, the other variable decreases or not, which we also call it as positive covariance. Or if is there any change in opposite directions, which we call negative covariance. That means if one variable increases, the other tends to decrease. In simple terms, it describes the relation between two set of numbers. So for here, continuous variables that are not part of the main experimental manipulation or in general the study design, but have an influence on the dependent variables are known as covariates. If there is a data set and we do any experiment on that data set, if there are variables which manipulate the results or which have an effect on the results from the data set, we call it as dependent variables and direct variables. Uh, so the analysis of how much these variables has an effect on the results from the experiment is called is what we calculate from the ANCOVA, which is analysis of covariance. When we measure covariates and include them in an analysis of variance, we call it as analysis of covariance or ANCOVA. For better understanding, some of the examples of continuous variables are like age, height, and temperature, which means if age is a continuous variable because we can take any value within a range like from 20 years to 80 years, we can take any of the value and it can be a age of person. So age can be a continuous variable. Same as that, like height and temperature can be a continuous variables. So these continuous variables are often like used for the analysis in statistical techniques, and these are suitable for ANOVA and ANCOVA techniques. So here is some example for ANCOVA. Suppose if we take a population where if we take a sample of from population where people are having some hypertension disease, and we are supposed to examine the effects of a new hypertension drug on people with high blood pressure. So let's think about some variables that can influence the hypertension other than the medicine which we're giving in the experiment. So these variables are some of the variables that can be is like if patients already have some codices, then it can be a variable that can affect the experimental result, or if the person is taking some other X drug along with this drug, that can have some effect on the blood pressure, and our results may vary. So these variables may include the number of other medicines the person is taking at the same time, or it can be the patient's age. If these variables, or what we call is covariates, these variables are measured, then we can include them in the regression model and control for their influence. Uh, so what exactly is this regression model is? So in ANCOVA, the regression model is a statistical model which we use to analyze the relationship between any of the two independent variables or any covariates or any dependent variables. So ANCOVA combines like elements of both analysis of variance and regression analysis to exactly examine the differences which we see from the variables in a data set. So when we outline these variables or covariates or any of the independent variables and then we include them in a regression model, we can we can understand what influence a variable is having on the results of the data set. In hierarchical regression, if we enter the covariate first and then enter any of the independent variable which has an effect on the experimental manipulation, we can see what kind of effect the independent variable is having on the results of the data set. Uh, what exactly is this hierarchical regression is? This is the analysis technique which is used to examine the relationship between any of the dependent variable and multiple independent variables, which while controlling for the effects of certain variables. So what predictors do is, in hierarchical regression, they enter different kinds of variables in a stepwise manner into the regression equation. This is a mathematical equation. So these enter the variables in a stepwise manner, so that it uh, with each step representing a different block of predictors. By doing this hierarchical regression, we can this one allows researchers to assess the incremental contribution of each block of predictors to a variance in the dependent variable, which means when we enter like in a stepwise manner, we can exactly understand what variable is showing what kind of influence from to the results of the data set. So uh, in hierarchical regression, if we enter the covariate first and then the independent variable, we can exactly see what kind of effect the independent variable is having on the results of the data set. So why should someone opt for this ANCOVA? Why should someone include these covariates in ANOVA is, by including this covariates in ANOVA, we can reduce the within group error variance, which we called as random error or unexplained variance. So in simple terms, what is unexplained variance is like, it's the difference between what you predicted and what the actual experimental result is. It's like the gap between what you expected to happen and what actually happened. This unexplained variance can happen for many reasons. There can be other factors besides decreasing the hypertension, or uh, how the drug works. Beside all this, there can be many other factors which we may not include, or which we may not rule out. So by doing this, we can actually reduce the errors, and we can work on the factors that affecting these covariates, so that we can make our experiment error free. And the second reason is we can eliminate confounding. So there is always a possible, like I said before, there is always a possibility of unmeasured variables, where we cannot rule out all the variables that affect the experimental result, which may have a significant effect on the experimental result. So if there are any variables that are known to have some influence on the dependent variable, and if we can measure the effect of those dependent variables, we can actually remove the bias, and we can make our experiment more closer to the true value. So which is why ANCOVA is opted. If there is a confounding variable and it can be measured and enter into the analysis of a covariate, then we can measure the effect of these independent variables more accurately on the outcome variable. If we know if we know how positive or how negative these independent variables are affecting on the results, then we can work on them. We can remove the bias, we can remove the possible errors that humans are making, and we can more accurately uh, come on work on the outcome variable. And also there are some other reasons which we can see from the Stevens book. What is this role of covariate in ANCOVA is, we have three scenarios: scenario A, B, and C. The first scenario will be part A, which is a basic ANOVA. Here, there is the total variance in hypertension. So for the part A, which is a basic ANOVA, the total variance in hypertension study, it can be explained by two things, which is a variance which is explained by the specific treatment drug which we're including in the experiment, and the other part will be the unexplained variance, where we cannot rule out some of the dependent or independent variables that are affecting the result of the study. So for part which is the basic ANOVA, and for part B, which is the ANCOVA, which is the ideal scenario for ANCOVA, because there is variance explained by the specific treatment drug like ANOVA. And for the unexplained variance, we can actually rule out some of the covariates, or like independent or dependent variables that can explain this unexplained variance, which these are the covariates that explains the part of an unexplained variance. Which means the covariates, like maybe the initial hypertension the patient had, these are the covariates, like it can be some other drug or patient's age, which explains a portion of the unexplained variance, by accounting for the variability in hypertension that the patient is having after the treatment, that can be attributed to the patient's different levels of hypertension that he had before the treatment, which means there are some other factors like uh, it can be like said, it can be the patient's motivation to have a drug or his adherence for the treatment, which can be contributing to the unexplained variants that were not considered in the analysis. And for part C, which is ANCOVA should not be used in this situation because the effect of the covariate overlaps with the effect of treatment, which means the experimental effect is confounded with the covariate effect. So in this scenario, let's think a pharmaceutical company which is offering a drug is testing the effectiveness of the new drug which they are offering in reducing blood pressure in the patients who are diagnosed with hypertension. So the company also wants to know the control for the effect of patients' initial blood pressure levels. So if we rule out the variables, the dependent variable can be the blood pressure because it is a continuous dependent variable, and the independent variable can be the drug treatment, where we can have like control and placebo. And the third thing, the covariates will be the initial blood pressure where the patient is having before the treatment. So in this overlap of effect, in the overlap effect, the initial blood pressure of patients might also influence the final blood pressure treatment. If patients who are having higher initial blood pressure levels, they might experience some greater reductions in blood pressures regardless of the drug treatment they receive, which means the effect of the covariate might overlap with the effect of the experimental factor. So from this we can have interpretation complexity, which means if the drug treatment is found to have a significant effect on reducing blood pressure, it could be challenging to determine whether this reducing blood pressure effect is solely due to the drug's efficacy or it is partially influenced by patients' initial blood pressure levels. So though lower the overlap of effects complicates the interpretation of the results, which is why ANCOVA is not suited for this kind of uh, type C scenarios.